What's something people don't know about thermal engineering? Today, let me take you on a journey into the fascinating realm of thermal engineering. Picture a world where heat and temperature are the main characters. From the warmth of our homes to the engines of our cars, thermal engineering is the silent hero. Imagine crafting rockets that soar into space or buildings that conserve energy. This is the magic of thermal engineering. At its core, it's all about how heat travels from hot to cold. This knowledge is crucial for creating efficient car engines and refrigerators. It empowers us to harness heat for energy, minimize heat loss, and maintain cool environments. So join me as we uncover how heat transfer shapes the world around us. Discover how thermal engineering is everywhere around us. Imagine a world where heat is constantly on the move, shaping our daily lives and the very fabric of our existence. This journey of thermal energy, driven by temperature differences, is a silent force behind countless processes. Picture heat as a restless traveler, always seeking to move from a warmer place to a cooler one. This natural flow is the heartbeat of everything from cooling our gadgets to keeping our homes cozy. Envision a steaming cup of coffee left on a table. As it sits, the heat from the coffee escapes into the air, cooling the drink and gently warming the room. This simple act is a dance of thermal energy. In this dance, there are three main steps: conduction, convection, and radiation. Each step has its own rhythm and role in the grand performance of heat transfer. Conduction is like a handshake, a direct transfer of heat through contact. Imagine touching a hot stove. The heat swiftly moves from the stove to your hand, a vivid reminder of conduction's power. Convection, on the other hand, is a graceful waltz through fluids like air and water. Picture heating water in a pot. The warmer water rises, the cooler water sinks, creating a mesmerizing circulation. Think of a pot of water boiling on the stove. The heat causes the water at the bottom to rise, while cooler water descends, forming a continuous, elegant cycle. Radiation is the sun's warm embrace, a transfer of heat through electromagnetic waves. Unlike conduction and convection, radiation doesn't need a medium to travel through, making it a unique player in the heat transfer saga. Each mode of heat transfer plays a crucial role in both natural phenomena and engineered systems. From the Earth's climate to the design of heat exchangers, understanding these processes is key to unlocking their potential. By mastering these mechanisms, engineers and scientists can design systems that are not only efficient but also safe. This knowledge leads to innovations that enhance our quality of life, from advanced thermal management in electronics to more effective heating and cooling systems. I bet you didn't know how heat moves through touch. Picture yourself holding an ice cube on a hot summer day. As the ice begins to melt in your hand, the heat from your skin is transferred to the ice. This magical process is conduction. Deep within the materials, tiny molecules vibrate and collide, passing energy from one to another. Metals, with their tightly packed molecules, excel at this energy transfer. On the other hand, materials like wood and insulation are the guardians, resisting the flow of heat. According to the wise Fourier's law, the rate of heat transfer depends on the temperature difference and the material's conductivity. Thermal conductivity is the measure of a material's ability to conduct heat, a crucial trait in our story. Understanding conduction allows us to craft better cooking pans, insulate our homes efficiently, and innovate in electronics. And so the tale of heat transfer continues to shape our world. You need to hear this if you're fascinated by the dance of heat in our world. Welcome to the fourth chapter of our journey, Convection, Riding the Heat Wave. Imagine a world where heat dances through the air and water, moving gracefully from one place to another. This dance is called convection, a mesmerizing process where heat travels through fluids like air and water. Alongside conduction and radiation, Convection is one of the three main ways heat moves, playing a vital role in both nature and human innovation. Picture yourself in a cozy room. Have you ever felt the warmth near the ceiling while the floor remains cool? That's the magic of convection at work. Warm air, being lighter, rises to the top, while cooler air sinks, creating a continuous cycle of movement. This enchanting principle isn't limited to air. It applies to all fluids, including water. Imagine heating a pot of water on the stove. The warm water ascends, while the cooler water descends, setting off a captivating circulation. This mesmerizing movement is known as a convection current. In boiling water, you can witness these currents as the water swirls and dances around. Convection comes in two forms, natural and forced. Natural convection occurs due to density differences, while forced convection relies on external forces like fans or pumps to guide the heat's journey. Picture a hot air balloon soaring into the sky. This is a beautiful example of natural convection. The heated air inside the balloon is lighter, causing it to rise majestically. Now think of a hairdryer. This is forced convection in action. The dryer uses a fan to blow air over a heating element, directing the warm air to dry your hair efficiently. Convection coefficients are like the secret ingredients in a recipe, determining how quickly heat is transferred by convection. These are crucial for designing systems that transfer heat efficiently. These coefficients depend on various factors, such as the fluid's properties, flow speed, and surface shape. For instance, a rough surface will transfer heat differently than a smooth one, adding another layer to the convection story. Convection is a key player in many realms, from weather patterns and ocean currents to heating and cooling systems. It drives the formation of clouds and storms, moves ocean currents that regulate our climate, and helps keep our homes comfortable. This is going to blow your mind. Welcome to Section 5, where we explore the fascinating world of radiation, or as we like to call it, feeling the heat from afar. Imagine standing in the middle of a desert, the sun blazing overhead. You can feel the heat, but there's no medium like air or water carrying it to you. That's radiation at work. This is the same process that allows the sun to send its warmth across the vast emptiness of space to reach us here on Earth. Radiation is all about electromagnetic waves traveling from the surface of an object, carrying energy with them. The hotter the object, the more energy it radiates. Picture a glowing piece of metal, radiating intense heat. You've felt this yourself when you warm your hands near a campfire, the heat radiating directly to your skin. The Stefan Boltzmann law tells us that the energy radiated by an object is proportional to the fourth power of its temperature. It's a powerful relationship. Emissivity is another key concept, measuring how well a surface emits thermal radiation. Different materials have different emissivities. By understanding radiation, we can design better solar panels, more efficient satellites, and windows that keep our homes comfortable. It's all about harnessing the power of heat from afar. I don't think people understand how thermal engineering affects their house and phone. Imagine waking up to a warm cup of coffee, feeling the cool breeze from your air conditioner, or using your smartphone without it overheating. All these everyday moments are made possible by the magic of heat transfer. Let's embark on a journey to see how heat transfer shapes our lives and powers our industries. In the heart of our homes, HVAC systems work tirelessly, using heat transfer to maintain the perfect temperature and air quality. Through conduction, heat travels silently through walls, floors, and ceilings, ensuring warmth or coolness spreads evenly. Convection takes over, circulating air to keep every corner of the room at just the right temperature. And then there's radiation, allowing heat to be absorbed or emitted by surfaces like windows and walls, playing its part in the thermal dance. Now, let's hit the road. In cars, heat transfer is crucial for cooling engines. These powerful machines generate immense heat and need efficient cooling to keep running smoothly. Radiators step in using convection to cool the engine coolant, preventing any chance of overheating. In the world of electronics, heat management is a silent guardian. Devices like computers and phones generate heat that needs to be carefully managed. Overheating can spell disaster for electronics, but with good heat management, they can last longer and perform better. Heat sinks are the unsung heroes, using conduction and convection to draw heat away from components, keeping them cool and efficient. In industries, heat exchangers play a pivotal role, transferring heat between fluids using conduction and convection, ensuring processes run smoothly. From power plants converting heat to electricity to refrigerators keeping our food cold, heat exchangers are indispensable. And finally, thermal insulation in buildings and clothing reduces heat transfer, keeping us comfortable and saving energy. Heat transfer is truly the invisible force that makes our modern lives possible. You need to watch this if you struggle with understanding heat transfer. Our journey through the realms of heat transfer comes to a close. We discovered that heat loves to travel from hot to cold. It embarks on its journey through conduction, convection, and radiation. These principles are the backbone of many fields, from the towering skyscrapers to the swift trains, and even the tiny microchips. So stay curious and keep exploring the wonders of thermal engineering. There's always another chapter to uncover. Dive into your library or explore the vast online world for more tales of thermodynamics and heat transfer. Don't forget to subscribe, like, comment, and share this video to keep the knowledge flowing.